concentrated. So if up here it's 300, down here it may be 600, maybe here it's 900, here is typically 1200 milliosmoles. So this is where my urine is going to get concentrated. All the water is being reabsorbed back into the blood. Here's my ascending loop. The ascending loop, you don't need to know this for lab, but you probably will need it for a lecture. There's a thin segment and a thick segment. This is impermeable to water. Water cannot come in or out. But what is happening is salt is leaving, going back into the bloodstream. So what would be the vessel that's surrounding my loop of Henle?
Vasa recta.
Vasa recta. Yeah. So this water, this salt, is going into the vasa recta that's surrounding my loop of Henle. Okay, so if we're 1200 here, 1200 milliosmol. But now I'm losing a bunch of solutes. Is it getting closer to 1200? Will it go down to 1400? Or do you think it'll start going back up to 3? It'll go back up to 3. With all this salt leaving, as we get back up here where the cortex is, it's actually at 100. So I'm hypoosmotic. It's hypotonic to blood. If this is 100 and blood is 300, this is hypotonic to blood. Okay. So now we're at the distal convoluted tubule. If this individual person was given $100 for every cup of water they drank, and they drank 30 cups of water, they have all of this water, okay, that they need to get rid of. So what's going to happen, this is going to stay diluted. It'll stay at 100. I don't know why my marker's not working. It's going to stay at 100. No water will be released here. It won't be reabsorbed back into the blood. Don't need it. We need to get rid of it. It's the water, all the solutes waste is going to go through the distal convoluted tubule into the collecting duct. Nothing's going to happen. It's just going to get released into this big amount of urine that contains lots of water and then the regular amount of waste. Okay. Say on the flip side, this person is lost in the desert and they need to conserve that water. What can you tell me about aldosterone?
That it's brought up multiple times in 211.
Okay.
It's Mr. Cox's favorite.
Yeah. It's going to have a conservative effect for water. Where is it released from? The adrenal cortex. You remember what zone? Yeah, zona glomerulosa of the adrenal cortex, of the adrenal gland. Aldosterone. Aldosterone is going to be secreted to conserve water. So what it's going to do is it's going to allow what's called aquaporins to be put in here and let all that water escape back into the blood. So water is reabsorbed because of aldosterone.
I thought you said no water was released there.
That's if the person had too much water.
Oh.
Yeah, so that was the flip side, when the person drank 300 gallons of water. But now this person is lost in the desert. It needs to conserve water.
Okay.
So when water needs to be conserved, aldosterone is going to be released by the adrenal cortex of the adrenal gland. And in the distal convoluted tubule, all that water can be reabsorbed. What can you tell me about ADH? Antidiuretic hormone. Yeah, same thing. It conserves water. Where is it released from?
Isn't that one of the pituitary?
Yes.
Yeah.
Posterior pituitary. That's right. Okay. So, ADH, antidiuretic hormone, is released to conserve water. It allows the collecting duct to have these aquaporins, so that whole lot of water can escape from the collecting duct and be reabsorbed by